Hi, this is K.Hari Babu, working as Associate Professor in MLR Institute of Technology. So now we need to discuss about problems on the Poisson random variables. First of all, we need to know Poisson random variable. So here, if the random variable x is discrete random variable, then the Poisson probability distribution function and density function, that is the probability density function fx of x is equal to summation of k equal to 0 to infinity e power minus b into b power k by k factorial into del of x minus k. So this is the probability density function. If you want to write probability distribution function, means fx of x is equal to summation of k equal to 0 to infinity e power minus b into b power k by k factorial into u of x minus k. Here we are using b. B will be taken as average value. So now, what is the use of this probability distribution and density function? That is, what are the applications of probability, that is Poisson probability distribution and density function? Generally, this probability function, distribution and density functions are used for counting purpose. So here, how many number of electrons are moving from cathode, or we need to find how many number of customers are arriving at particular filling station or whatever may be. In that case, counting purpose, we are using this Poisson probability distribution and density function. Now we will go to problems. See here, first one, a certain large city experiences on an average 3 marriage events per week. So here there are 3 marriage events, be equal to 3 marriage events. On average, we are using 3 marriage events. This occurrence follows a Poisson distribution function. So this is represent the count, means, so this is the Poisson distribution function. So now what I need to do, what is the probability that there are 5 or more than marriage events in a given week? I want to find the probability of, in 1 week, the city is expecting more than 5 or more than, that is 5 or more than marriages in that week. So here I need to find the probability of k is greater than or equal to 5. So here I need to convert this value in terms of the probability distribution function. We can write, that is p of k greater than or equal to 5 is also equal to 1 minus p of k less than 5. Otherwise, we can write 1 minus p of k less than or equal to 4. So here this is the probability distribution function, that is Poisson probability distribution function. Now I can find 1 minus summation of k equal to 0 to up to 4 e power minus b into b power k by k factorial. So now we can write 1 minus, here e power b will be taken as 3, that is e power minus 3 into 0, that is b power, b means 3 power 0 by 0 factorial plus 3 power 1 by 1 factorial plus 3 power 2 by 2 factorial plus 3 power 3 by 3 factorial plus 3 power 4 by 4 factorial. So if you want to simplify this one, means you can get, that is 1 minus e power minus 3 into, this is 131 by 8, also equal to, approximately equal to 0.18. So this is if a large city can expect 5 or more marriages in that week, that is 0.18. Now we need to move to the second one. On an average, how many weeks in a year can this city expect to have no marriage event? So he is asking in 1 year. First of all, I need to find the value for 1 week. After that, that will be converted in terms of the year. So here, on an average, how many weeks in a year can the city expect to have no marriage function? So means that will be taken as k equal to 0 value. So now we can write, that is k, I need to find the probability of k equal to 0. That is e power minus b, that is e power minus 3 into b power 0 by 0 factorial. So that is e power minus 3 into 1, that is e power minus 3. That e power minus 3 means that is 0.04 like that. So that is, if the city can expect 0 marriages in a week, but he is asking in an year. So means generally year contains 52 weeks. Now in a year there is no marriage event in the function, means that is 0.04 into 52, that is approximately 2.5. So this is the no marriage in that year. Next orbit, how many weeks per year can city expect the number of marriage events per week to equal or exceed the number for week? So here we need to find, we know already average value. Average value is given as 3 marriages. Now what he is asking, we need to find in a week the probability of, that is in a week the average value must be greater than or equal to 3. That is P of k greater than or equal to 3. This will be getting in a week, but I need to find in a year. First of all, I need to find for week, means P of k greater than or equal to 3. So also converting in terms of, that is P of k greater than or equal to 3 also equal to 1 minus P of k less than 3. Otherwise, we can write 1 minus P of k less than or equal to 2. That is 1 minus e power minus b into b power k. That is b power k 0 by 0 factorial plus 3 power 1 by 1 factorial plus 3 power 2 by 2 factorial. So that is, if the city can expect on average more than 3 marriages in the week, means we can get 1 minus e power 3 into 3 power 0 by 0 factorial, 3 power 1 by 1 factorial, 3 power 2 by 2 factorial. If you want to simplify this one, means we can get, that is 0.57 like that. So now he is asking, we need to find in 1 year, that is into 52, that is 52 into 0.57, this is approximately 30. Now we are moving to the another problem. So here, assume that the number of automobiles arriving at the gasoline station is Poisson distribution and occurring at an average rate of 50 per hour. That is, lambda is given, lambda is equal to average rate, lambda is equal to 50 per hour. On the station has only one gasoline pump, and if all cars are assumed to required 1 minute to obtain the fuel. So here time also given, 1 minute, time is showing in terms of the minutes. And what is the probability that a waiting line will occur at the pump? First of all, I need to find B value, that is B is equal to lambda into T. Here lambda is average rate will be taken as 50 per hour. Hour means I need to convert in terms of the minutes, that is 60 minutes into T is 1 minute. So that is 5 by 6. So this is B value is 5 by 6. Now what he is asking, you need to find what is the probability that a waiting line will occur at the pump. So here, if the waiting line is occurring at the pump, means if the number of cars are available at 2 or more than 2 cars will be available at the pump, means then only the waiting line will occur. Other than that one, there is no waiting line, means if there is no car, there is no waiting line. If one car is there, means there is no waiting line. If more than one car, means waiting line is occur. So now I need to find the probability of K waiting line must be greater than 2. greater than or equal to 2. 2 or more number of cars will be available means waiting line will occur. Means we need to find P of k greater than or equal to 2. So now we can write P of k greater than or equal to 2 is also written as 1 minus P of k less than 2. In terms of probability distribution function, we can write 1 minus P of k less than or equal to 1. So we can write 1 minus summation of k equal to 0 to 1 e power minus b into b power k by k factorial. So here that also equal to 1 minus k equal to 0, that is b. What is the b value? B value means 5 by 6, that is e power minus 5 by 6 into 5 by 6 whole power 0 by 0 factorial plus 5 by 6 power 1 by 1 factorial. So if you want to simplify this one means we can get 0.203 like that. So this is the answer for this one. So next one we are moving, that is if a large hotel, it is known that 99% of the people are returning the room keys when checking out. 99% of the people are returning the room keys. Okay. If 250 members are checking out of after large conference, if 250 members, then will be taken as 250 members check out after a large conference, 99% of the members are returning the room key. So what is the probability that not more than 3 will fail to return the room keys? Not more than 3 will fail to return the room keys. Now, what is my random variable? I need to assume my random variable will be taken as not returning room key persons. Not return room key person means, so here will be taken as, that will be assumed taken as P, and 1 minus P will be taken as returning room keys persons, otherwise Q. So here what he is telling, 99% of the members are returning the room key means will be taken as 99% means what is the P value? That is 1 minus that one will be taken as 99% means 0.001. So here, so this is the probability not return the room key persons will be taken as P equal to 0.01. So now here total number of persons n equal to 250 and P will be taken as 0.01. See here, this is related to the Bernoulli problem. In that Bernoulli, we are using two rules. One is the de Moivre approximation, second one is the Poisson approximation. In this Poisson approximation, if n is very large and P will be taken as very small, n is very large, P is very small, so this belongs to Poisson distribution function. Here n is 250, P is 0.01. So here compare with n, P is very small. That's why this is decided to the Poisson distribution function. So now I need to find what is the probability that the not more than 3 will fail to return the room keys. I need to find the probability of K is less than or equal to 3. What is the probability of K less than or equal to 3? So now I need to convert this value in terms of the distribution function, that is P of K less than or equal to 3 is also equal to 1 minus P of K greater than 3. Otherwise no need to write this one also. Directly I can write P of K less than or equal to 3 means simply I can write in terms of that one summation of K equal to 0 to infinity or K equal to 0 to 3 e power minus NP into NP power K by K factorial. So now I can write also equal to e power minus NP, that is minus n 250 into 0.01 into 250 into 0.01 power 0 by 0 factorial plus 250 into 0.01 power 1 by 1 factorial plus 250 into 0.01 power 2 by 2 factorial plus 250 into 0.01 power 3 by 3 factorial. So this is approximately equal to 0.75. So this is the, that is more than 3, not more than 3 members will fail to return key probability is 0.75. Next, we are moving to next problem, that is a supplier receives 100,000 shirts. So here total number of shirts. A supplier receives 1,000 shirts from the textile company. The probability that a shirt is defective shirt is given. So here defective shirt is 10 power minus 2. Find the probability that there will be more than 5 shirts are defective. We need to find the probability. Here first of all I need to assume the defective random variable will be taken as x, that is x must be greater than 5. I need to find the probability of more than 5 shirts are defective, that is p of x greater than 5. So you can write 1 minus p of x less than or equal to 5 also. See here, in this one n is given 1000, p will be given as 10 power minus 2. So here n and p values are given, means this is belongs to Poisson. How can we say that? N is very large, p is the probability will be taken as very small. So we can decide this is the Poisson probability distribution function. So now we can write that also equal to 1 minus summation of k equal to 0 to, otherwise you can write x or k. K is p of k less than or equal to a equal to 0 to 5 e power minus np into np power k by k factorial, that also equal to 1 minus, we need to substitute k value, that is e power minus n 1000 into p 0.01 into np. So means 10, n into 1000 into 10 power minus 2 means 10 power 0 by 0 factorial plus 10 power minus 1 by 1 factorial, 10 power minus 2 by 2 factorial, 10 power minus 3 by 3 factorial plus 10 power, plus 1 np power k, that is 10 power 4 by 4 factorial plus 10 power 5 by 5 factorial. If you want to simplify this one, means this will be getting is approximately 0.9. Yeah, thank you.